Hello and welcome to the latest video in our series on DevOps and testing. And in this video, we are going to be looking at how to add a performance test to the .NET application that you've been working on so far. So remembering back to what you learned about performance tests. These types of tests measures things like how the system performs under load, helps us identify things like bottlenecks or slow response times, scalability issues, right? We really want to make sure that our application is ready for real-world traffic, and it helps us plan our infrastructure needs. So what we're going to be doing in this video is walking through how to set up a test method in the test class that we've been working on so far, our API integration tests section, and do a little performance testing to see if we get a response within an acceptable time frame, and then how we can add that into our GitHub Actions pipeline. So if you haven't been working with me so far and you don't have this .NET application, you'll want to back up and you'll want to take a couple of steps back in our videos where we set up our .NET project and added our integration test. And in the last video, we set up our smoke test, which is not a prerequisite to doing this step. You at least need the API integration tests test class set up to go with our web application, our little ASP.NET web application that has this multiply endpoint we are going to work with today. So if you need to take a moment, back up, go get ready. But if you have been following along with me and you're ready to go, we're going to jump right into the end of our API integration test section here and start setting up a new test method. And we're going to set this up in its test category of performance. And our new method, we're going to set up a public async task for the multiply endpoint. And we want to say responds within, I would say 500 milliseconds is a good benchmark. I know these names of these methods start to look really long, but it is more of a convention that your names of your methods are descriptive as to the endpoints that they're touching or the components that they're using, the responses, or what it is that they're actually testing. So don't be afraid to make kind of longer method names with your tests. Your test manager and the other components that we use to, running the GitHub Actions and seeing those, we don't really care how long the names are. So don't worry about that too much. So I'm going to set up a stopwatch. And if you are maybe someone familiar with .NET, you have maybe worked with stopwatch before, and it's under the system.diagnostics library, and we can set up a stopwatch and we can say start new, which will start ticking, and then we can make whatever calls that we want to check that are happening within that time frame. So I'm going to call that multiply endpoint. So that is our /multiply. And we need to pass it a value for A, and we need to pass it a value for B. And so once that comes back and we have something in response, we can stop the stopwatch. And so then we can verify using our assert, did we get an OK status code, and did the stopwatch stop within 500 milliseconds? So I'm going to use an assert here for our equal, and we can look for that HTTP status code being OK. So we can say HTTP status code OK. Somehow I got an extra HTTP in there. Perfect. And then we can also assert using isTrue stopwatch elapsed milliseconds. So that's going to tell us how much time actually ticked by while it was running. So we want it to be less than 500. And then we can put in a message that will display if that condition is false. So you can see there in the IntelliSense is trying to help us out. The message is included in the exception if this statement doesn't come out true. So I'll put something like expected response time was under 500 milliseconds. But was, and we can include the stopwatch elapsed milliseconds time in there. I know it's a hard line to see the end of, but we've got to add that $ in there to make sure that we are using the string correctly. So expected response time was under 500 milliseconds, but was, and it will give us the actual, and you can see I put the little MS there at the end just to make that look nice. And so that is our test that we want to run. So start the stopwatch, make the check to the endpoint, stop the stopwatch, and then did it happen within the time frame that we wanted it to happen in. So if we want to check this out just locally, we can run our application, come to our Test Explorer window, which you find under the Test menu, and we can see there's a little blue mark here because our endpoint here has this test method has never been executed. So it'll show green for passed, red for failed, blue for never run. And so we could run our tests. In this case, I don't think it's going to actually run locally correctly because it's a performance test and we're actually wanting to test it like on the server, and the local server is always going to be super fast. So we want to go ahead and add this to our GitHub Actions pipeline. It may let me run it. I was actually going to try. Let's see. Run the, I clicked on it and said run test. Now, yeah, okay. Run, the test was run in 585 milliseconds, so we can see this up here. So it looks like we passed, and we didn't output a message or anything to actually tell us how long it took. But again, you want to be really careful running tests like this on your local system because it's not going to be anywhere close to what it actually takes to run it on your like live production system. But that's okay. We're going to come over to our .NET YAML file, and we are going to add a line in here for running our performance tests. Man, you know, YAML, so picky about the copy paste. You got to be real careful. Okay, category performance. Now, we talked about last time, you know, we place smoke tests before all of our other items because smoke test is really, you know, hey, you've really broken everything and nothing is working, and so you really don't want to proceed with any other tests. But with performance tests, they're typically lightweight and we want to test them every push, and it doesn't really matter where they go as long as they go after the smoke test. So adding this to our file down here at the end is going to be a great place to put it. So I'm going to say update for performance test and commit that and get that pushed up to GitHub so that we can take a look in our GitHub window, refresh, and we can see it running. Come in here and inspect, and we can watch each of the steps as they go. So we got through our smoke test, we got through our unit test, we got through our integration test, we got through our performance test, we do our post setup, and all good. We got a nice green check. That's what we want. And as you can see, our pipeline is starting to get quite full. And so that is generally what happens. And remember, we've talked a lot about ways that we can make these steps as quick as possible so that your developers aren't sitting there twiddling their fingers for 10, 15 minutes while you wait for all your pipelines to run. It can be a very frustrating experience. So at this point, you hopefully kind of have the hang of adding these different types of tests and what they look like. And you're probably saying to yourself like, oh, and a performance test and a smoke test and an integration test all pretty much look like the same thing. We're just calling them different things. And that's true, but we call them different things because they're serving different purposes and they happen in kind of different places of the cycle. And as you have a lot more tests that fall into these different categories, we really wouldn't have more than one smoke test. And our performance tests are going to look very different depending on what it is that we want to measure. Is it response time? Is it throughput? Is it error rate? Is it CPU usage? We can test all kinds of things that look very different from what's going on in these integration tests to make sure that, components are talking to each other, or even in our unit tests where we were looking at individual methods and making sure those returned values that they should return. So I hope you have really learned a lot. This is going to be the last video that I'm going to show you on how to add all of these different tests. I know we talked about a lot of different types of tests, but without building out and really making things bigger, this is about as far as we can go. We discussed regression testing, which is just retesting previously working features. So those really aren't different tests to implement. They are the same tests, but they're just retesting to make sure surprise bugs didn't sneak into production. Functional or end-to-end testing is a little different looking because we don't have a UI or those kinds of things. And I would strongly recommend, if you want to get into UI testing and learning some of these UI tools like Cypress or Selenium, definitely jump down that rabbit hole. And then security testing is often looking at the code itself, and there are some tools that we can use for that, but it doesn't look anything like what we've been doing so far with our GitHub Actions and these different types of tests. So I hope you have enjoyed this. I hope you've learned a ton. As always, if you have any questions, I'm happy to take those. I'd say see you in the next video. Hopefully you continue to check out my catalog and find more things to learn when it comes to software development. And I'll catch you later. Thanks so much.